Wednesday and all of Thursday. Okay. So if I remember correctly, we finished chapter 11. Let's kind of review what we did last time. Bless you. Oh yeah. This is what I was hoping you guys might have questions on. So here's something. This is what we did last time. If I told you that this is the formula for the amount of precipitation in Sonoma, California, where X is the month, so like January would be 1, February is 2. Everybody with me? So X goes up to 12. All right. In what month would there be? What is this going to have a max or a min? How can you tell? Why would it have a min? It opens up. It's positive 0.2, right? If it opens up, it's going to have a location where it's the minimum output. Let that just make all the sense in the world, right?
And that's going to be just like the first, what do you call it? Where the x squared is? That's always like the number in front of that.
Yeah. It's just like, is this going to go up or down, this line? Is it going to go up or is it going to go down?
Down.
How do you tell?
Oh, because it's
in front of the highest power of x. Now, this doesn't carry through for everything, trust me, but it's related to that. That first number is kind of related to the slope. Since it's positive, it's opening up. Okay, it's negative. So there's going to be mins. Thankfully, the question is, when is there the minimum precipitation? What month has the minimum precipitation? What does X represent again? Somebody remember?
the months.
The month. I love it, right? So what am I trying to solve for then? What am I trying to find? The minimum occurs where? At the what?
At the very bottom.
I'm pointing to it. The vertex. All right. So when you see a problem that involves a quadratic function, what the shit does quadratic function mean? Degree 2. And they ask you for a max or a min. They ask you to optimize it somehow. A maximum, a minimum. You see that as find the vertex. Right? If I said, when does something happen, that's finding X. If I said, what happens, like what is the amount of precipitation when it's the minimum, then you have to plug X in to figure out what the precipitation is. Right? Precipitation. How do I find X part of the vertex? How do I find the X part of the vertex? What's the shortcut? You could complete the square. You want me to make you complete the square? If I were you, I'd say, no. Thank you.
You can plug in the,
What's the shortcut for the X part of the vertex?
negative b over 2a.
Yeah. You need to memorize that. Where the hell did that come from? Quadratic formula. What's quadratic formula? Negative b plus or minus stuff over 2a. So it's the whole idea of this is going to be in the middle. That must be where the vertex is then, because the vertex is in the middle of everything. That was the shorthand of the 5-minute lecture I gave about that. That's where that shortcut comes from. So it's easier to memorize it if you know why it makes sense. So what's b in this case?
2.8. Negative.
Negative 2.8. And what's a?
0.2.
Good. Yeah, don't need to multiple. Yeah. So how do I do that? So I get 2.8 over 0.4, which is 28 over 4. How did it get from here to here? What did I do? Yeah, really I multiply by 10. Top and bottom. That's completely legal, which ends up moving the decimal, which now it's just 28 divided by freaking 4, which is 7. I love you guys. What's that represent again? What does X represent?
Oh, July.
That would be July. That's the month. That makes sense. In California, when do we have like negative rain? In June, July on here. So this is July. That's the answer to the question. That's when the least precipitation. If I ask you how much precipitation do they get in July, what would you do?
Plug it in.
Yeah, plug that in to X. Because what does this function tell you? The precipitation for some month. How are we doing? You all right, Lance?
Only in math can you do an equation. The answer is July.
Not really. Yeah. It kind of shows you the power of creating functions. Whatever I let X be, when I solve for it later, that's going to be what it is. I mean, so X is the month. So of course the answer is going to be a month then. That's what X represents. Numerical position of a month. Okay, maybe. If you do take statistics, you would see how to create functions that represent certain things. Well, if you take other things too. All right. But that's the main idea of section 11.8. The negative b over 2a shortcut and how to use it in real life. All right. So if I had a cost function, right? Let's say it's so for the X would be the number of widgets I make, and C is the cost. How many widgets would it make to have the least cost? In this case, actually I made it the most cost. Oh well. How do I tell it? When would it be the most? What tells me it would have a max?
-0.1.
And what's A? -0.1. Just because I wrote it out of order doesn't change what A, B, and C are. A is the number in front of X squared. B is the number in front of X. C is the number by itself. I like it. So they can use the same idea to find the max of this. Are you guys semi with me? So last time we did several where we actually had to create our own function. Right, there was that one with the side. One side was the barn. So I can't remember the other parts. They're all in the green book. Okay, so that's 11.8 in a nutshell. If I wanted to really summarize 11.8, there it is. That's a use of that in real life. And I know some of you don't believe this, but this is exactly what we do in real life for quadratic functions. Is every function quadratic? No. So then we have to develop other ways to do things for more advanced problems. Right? But this is where we start. Okay. So we desperately need to get into chapter 12. We more than likely will only do like a real surface level of 13 and 14. We're not going to have time to get that deep into 13 and 14. Definitely not 14. 12 is crazy important. And it starts off as something we should be used to. Let me put down something that should look very familiar. Okay. So let me just make sure you guys remember how these work. How would you find g of -7? Where? Yeah, not this one. Now. All right, so they get the cube root of -7 minus 1. What's that? Yeah, cube root of -8, which is -2. I like it. So that's the, remember this. Remember? Not too bad. Basic idea with function notation is substitution. You substitute this in place of x. All right, now. We also did this. Let's see if you guys remember. What is f of w? Two minus
X.
no, that's
W.
f of x. What's f of w? 2 minus w. See, now don't make too much out of it. What does a function do? Whatever's here, it replaces that with it. Okay, what's there? Freaking W. So what do you put there? Freaking W. Right? Don't make too much out of this. So what is g of 2x plus 4? Try to figure it out. So what am I going to put here? 2x plus 4, yeah. See, I mean, it's so, everything in math is very single-minded. It's what we have to do after we do that first step that gets people tripped up. I'm going to have to do some simplification after that. Ooh. But the first step is replace x with whatever's in here. Okay. Put 2x plus 4 there, minus 1. So I get cube root of 2x plus 3. Can I do anything with that? No. I'm done. Right, make that look more like a 3. All right, so there's nothing new about that. We've done this kind of thing before. We put little expressions inside. It's the same idea, substitution. So you guys looking at me like, I've never seen this. Is this familiar? Do you remember this? No. You guys don't remember any of this. Do you remember this? Yes. Fake it for me, because we did this a lot before. Now, you might not remember this. This you should, but you might not, but you can see the idea. This one you might not remember so much, but again, it's just replace x with what's there now. That's all it is. So, here's something a little new. But not really. Let's see if you guys pick up on this. What is g of f of x? So what am I putting into what?
Putting the other
Whatever
equation
after
into
that.
that one.
Yeah, putting what into what exactly? Putting the
F of x
F
equation
into g. I love it. Because what is f of x?
2 minus 3.
2 minus x. See, so all you got to do is exactly like the last one we just did. It just doesn't start off. It doesn't put. It says put f in there. And you're like, well, what's f? Oh, that's f. Okay. Put that in there, right? And then you do it. Put that in there. And what do you get? So you see that? I replaced x with what was in here. That's all I did. And now you simplify it if you can. And of course, what do you get there? Nothing major. Yeah. Cube root of 1 minus x. Bam. So this is what's called composition of functions. This end function is composed of g and f. That's where composition comes from. Maybe. You guys love this. But again, it's just substitution, not difficult. This does not mean g times f. This is f in g. I can't read you guys at all. You all right? All right. So how about this? Let me introduce you. So what I just wrote, does this make sense? This is what we're used to, isn't it? Put this thing into this thing. I know it's a little freaky. You got to, oh, that goes there into this. Okay. Here's the official symbol for this. Stupidest thing, but I just want you to see what it looks like. Good old goof function. This is the g of f of x. I hate this. You can just immediately take, if you see the little circle, you rewrite it like this. So what would this mean? The fog function. I love it. This describes how students feel in a fog. What's a better way to write this? F of g of x. Again, I hate when they introduce a symbol that we don't really need. Like this radical symbol. Why did we need it? We didn't need it. It's their shit. This symbol is stupid as shit. Sorry. Trying to be very honest with you. If I see this, I immediately write it like this. Now what do I do next to figure this out? What am I putting into f? G. And what is g?
Cube root of x minus 1.
Cube root of x minus 1. And I just take this and you plug it in f. And this is where some of you guys are going to try to do too much. I can't do shit to this. That's it. I put that there, and there's nothing I can do. There's nothing I can put together. How are we feeling so far? Is that all right? So if you see this in the book, and you will, rewrite it like that immediately, because that's the way we're used to it. Unless you like this, then you should be happy about the textbook and the way it does things. Okay? So that's composition. That's nothing new, to be really honest. It's really nothing new. Here's the truly new thing. Here's the thing we haven't really talked about how to find. I've used this word before. It's called the inverse function. So what's your gut tell you? What does your gut tell you about the inverse of this function? What does this function do to something? For anything I put into it, what does it do to it? That's 5. What should the inverse function be? Take away 5. Isn't that crazy? And here's the symbol we use for it. This is a really unfortunate symbol. And I know I keep harping on symbols every now and again, but it really is historically a bad idea. But this is the symbol for inverse. This does not mean reciprocal. This means the function that is the opposite of this one. Now that was a simple function. We have to develop a way to find the inverse given any function. Okay. So let's kind of sneak up there. Let's sneak up on it. What do you think? All right, so just conceptually. Oh, shit. You guys are going to love it. This isn't that bad. If f takes 1 and makes it 6. Now let me stop there for a second. Can somebody give me an example function that would do this? Wouldn't that function do this? What's f of 1 here? 6. What other function would do this if f of x was... What else can you do to 1 to make it become 6? What about you just multiply? So maybe if f of x was 6x, right? Then this would be true. You with me? Or if it was 2x plus 4, or 3x plus 3, or 4x plus 2. There's a billion, infinite number really. All right, just wanted to put that out there for a second. But let's say this is all I'm telling you. I don't even tell you. You realize there's an infinite number of things that would do this. I'm not going to tell you what it is. I am going to tell you f inverse exists. Now please, don't make too much out of this. What do you think f inverse of 6 has to be? No. No. What did f do to 1? It could have, right? It could have been, but the f is just whatever. This is one possibility for it. But what did f do to 1? It made it become 6. How? I don't know. That's one way. You with me? So what should the inverse do to 6? It should bring it back. It should undo what was done to it. F did something to 1 and made it become 6. So f inverse should take 6 and make it become 1 again. Let's think about it. What if it was this? Watch. Here's the inverse function, right? What do you get when you put a 6 in? 1. What if the function would have been, this is the other option I heard, right? What if that would have been the function? Isn't that still true? Is this true still? Mm-hmm. When you put a 1 in, do you get 6? Yes. What's your inverse function? This is a simple function. What's the opposite of multiply by 6? Holy shit. They're not all going to be that easy, by the way. Don't get excited. These are very simple. This is adding 5. This is multiply by 6. What if I'm doing a cube root and then adding 7 or something? Holy shit. I'm going to have to develop an algebra. These are simple, though. I can see them on sight. Multiply, so the opposite should be divide. What do you get when you plug a 6 into this? 1. Whatever the shit f does to something, f inverse is going to undo it. I don't even have to know what f inverse and f are. if F inverse exists, it will undo what was done. Let me let that sink in. So if I had G and G inverse, they both exist. If G of 7 is 11, what is G inverse of 11?
7.
Freaking 7. Of course it is. Did you know what G was? Do we know what G is? No clue. I have no idea what G is. I don't need to. If G makes 7 become 11, G inverse will make 11 become 11. We'll take 11 and make it 7 again. Let that make sense. That is the opposite function. So whatever this does to 7, this will undo it, bring it back to 7. This is how we doing so far. I mean, the inverse function, that's what its job should be. Bring it back to what it was. Right? Okay, maybe. All right. So notice this. See how it switches those? Input becomes the output, output becomes the input. Do you see that? Okay. So, here's the next level to this. This is where things get really kind of cool if you let them.
What does it say?
Given. No time to write well, as you can tell. Let me ask you something here, all right? So is everybody, I'll let you go ahead and copy this down if you want to. Is that going? Good. If I said, what input gives you an output of 2? How many answers are there? What input gives you an output of 2? 2 gives you an output of 2.5, it looks like. What input?
1.
1 gives you an output of 2. Ding, ding, right? Is there any other input that gives you an output of 2? No. In fact, this whole idea, so I'm going to try to find an inverse for this. So f of 1 equals 2, that must mean if the inverse exists, I have to be able to work backwards. So if I ask you, if I say I have an output of 2, what must the input have been? Can you tell me? Yes, because there's only one thing that has an output of 2. Let me see if you guys remember. Why is this a function? Why is this a function? Anybody remember? Mm-hmm. Had to do with Highlander, if you like Highlander, or if you don't. I don't remember it. For each x, there could be only one y. For every input, there can only be one output. Has to pass the vertical line test.
Oh.
I like it. Now, in order for an inverse to exist, not only does for every x there has to be one y, but for every y there has to be one x. It has to go both ways. Why? Because I'm trying to go both freaking ways. Right? If I said, I just squared a number and I got 16, can you tell me what that number is in one try? Mm-hmm. Tell me. I just squared a number and got 16. What's the number I squared? 4. You're wrong. It was -4. Sorry. Do you understand my point? Mm-hmm. Parabola won't work. This shit won't work. If I say I have an output of this, well, how many places have an output of this? 1, 2. Oh, shit. I can't find this guy's inverse. Because there's not a single function that goes to both. There's 2 outputs. In this case, 2 inputs. So this one, now here's the shortcut. Let's graph this, and I want to show you how this relates to what I was just talking about. So this will have an inverse because it doesn't go back on itself. There's nowhere where there's an output that's gotten more than once. Okay, I like it. And right now I could actually say this. So to be a function, you have to pass the vertical line test. To be an invertible function, you also have to pass the horizontal line test. Oh, shit. See how parabola fails horizontal line test very quickly? I can't find an inverse because if I said I got this output, how many inputs could there be? 2. Aw, shit. And then some functions are really, really, really bad. I got this output. I don't have a freaking clue, dude. There's too many possibilities. So it's got to be something that is a function first off, but it doesn't come back on itself. So, tell me this. What points does this guy go through? What point is this? Negative 3? Negative 2?
0,
This is that one we just talked about, and then this one is 3, 3. So the function goes through, I should do that in green, but too bad for me. There it is. Function goes through negative 3, negative 2, 0, negative 1, 1, 2, 3, 3. What must the inverse function go through? What does the inverse function do? It takes these and flips them. So what points will the inverse function go through? Negative 2, negative 3, sorry. Negative 1, 0, right? Is this hard? Turn this around. 2, 1. Don't change the signs at all, and then turn 3, 3 around. Can't go wrong there. Now watch, this is kind of cool. This looks like Nazca lines to me. You guys know Nazca lines? Look them up. They're in Peru. They freak you out if you think about it for too long. So if I graph these points, negative 2, negative 3, negative 1, 0, 2, 1, and 3, 3. Do you see some symmetry there? Isn't that kick-ass cool looking thing? Right? I'm sorry, it just is. And you're all like, sure. Where would the mirror be?
Right through?
Right, how right through it? So at an angle, right? In fact, it would be at exactly a 45 degree. It would be this. What line is that? What line is that? What point is this? 3, 3. What point does this look to be? A 1/2, 1/2. What point is this? 0, 0. So that's the y equals x line. Y equals x. Why does it make sense that when I do this, it flips over the y equals x line? Because how did I get it? I switched the x and y. So visually what happened? It flips over the y equals x line. It's neat. So one way to find the inverse visually is to just take all the points and flip them around. Do I even know what the function is? No, I just have a picture of it. But that's a lot of information. That's actually answers to the function. I can take them, turn them around, redraw it. I've got the inverse. I know what it looks like.
Oh, you said the blue line flips over the x?
The blue line flips over the y equals x. So the green, if you flip it over the y equals x line, you get the blue. Do you guys see that? That's where the mirror would go, right down there. I like talking about this now because we just talked about axis of symmetry with parabolas. That's the mirror. This is a little more complicated mirror. It's at a 45 degree angle, but you can see it. Okay. Now, so here's what kicks, if you let it kicks so much ass about inverses. What do inverses do? They switch the x and y. It's basically what they do. Whatever this guy did to negative 3, this guy's going to undo it, bring it back to negative 3. So let me ask you this question right now. What is f of, let's say f inverse of f of 2? See if anybody can put all this together. It's not even this one. Let me say g here so you know it's not related to the function we just did. G inverse of g of 2. G does something to 2, right? What is g inverse going to do to that? Undo it. So what's the answer going to be? Freaking 2. These kill each other. What's the cube root of 2 cubed? In fact, you've seen me do this, right? Why do I do that? Because these are inverse functions. What's the inverse of cube rooting? Cubing. So what will happen if you have both of them acting on each other? They will kill each other. They're like particles and antiparticles, right? Just not so much energy released when you do it, thank God. So this represents that idea more generally. If I have any inverse in its function, they will kill each other if one is inside the other one. So let's, next thing I want to do, I want to develop an algebraic way to find the actual function, the actual inverse function. If I know the function, I have to be able to figure out its inverse, algebraically. This is visually. I don't have a clue what the functions are, but I got a graph of it. Yay. So if I'm given a function, how do I find its inverse? And the answer is what I said earlier about the basic idea of what inverses do. They switch the x and y. So let's say I'm given, let's start off with the way you're going to see it. F of x equals, become an equals, x cubed plus 3. Where's the y in that statement? There's a y in this statement. Where is it? What took the place of y? F of x. So bring y back. Bring in y back. Now here's the step that I always put a little dotted line, because I'm not going to do anything algebraic. I'm going to apply an idea. If I'm trying to find the inverse, I switch the x and y. I really, really want this to make sense. If I do this and I solve for y, what will I end up doing? I will end up doing all the opposite stuff, won't I? Please let that make so much sense. What's the inverse supposed to do? All the opposite shit that this one does. So if I do this, why do I do this? Because it's based on what we just did earlier. It's what makes sense. Also, it makes even more sense because what do I do when I start to solve for y? I'm going to subtract 3, and then I'm going to take cube root. So I get y equals the cube root of x minus 3. So I get f inverse of x is the cube root of x minus 3. Let me ask you a few questions. What does this guy do first when I put something? If I put a 2 in there, what's the first thing you would do to 2? Cube it. What's the last thing this thing does to something? Cube root it. What's the second thing this guy does? Adds 3. What's the first thing this guy does? Subtracts 3. Do you see how it does all the opposite things in the opposite order? So real quick, what is f of 2? Figure it out. You can do it. Huh? 11. 2 cubed is 8 plus 3 is 11. What is f inverse of 11? Put it in. You should know what it's supposed to be. What do you get? 11 minus 3 is 8. What's the cube root of 8? Frickin' 2. That made 2 become 11, so this is going to make 11 go back to 2. Kick ass. This isn't some picture I made. This is an actual frickin' function and is doing exactly what I said it would do. Ha ha. Sorry.
So would we have to put plus or minus here?
No, because this is a cube root.
Okay, so it only works when you put it first. Square root.
Yes.
Okay.
Later in math, if you go much further in math, you will learn, for example, this equation, if this was x cubed plus 3 equals something, there should be 3 answers, right? We already know that. I already told you guys that. There's a cube, so it should have 3 answers, right? 2 of them are complex. In fact, maybe I'll do that problem in a minute, just so I can show you. I want to go a little further with this. I'll do a little handout, but later I'm going to do this with you. I'm going to solve this and get 3 answers. Some of you guys can see 1 answer, right? You know, like you're saying as well. I'll do that later. Haha, little teaser. I'm surrounded by little things. Can you guys see them? Mm-hmm. All right, it isn't just in my head. Okay. What was the last thing? I think that's enough. Yes, I can give this to you. I wasn't going to do anything else there. I don't think, yeah. So let me give you this. One side has a lot of writing on it. Do not worry about that side yet.
Square root. On a cube root. So for the first one, you just plug in 2 x. And then you got 11.
Yeah, if you put a 2 in, you get 2 cubed is 8, plus 3 is 11.
Yeah, so that's just...
If you plug 11 into this one, 11 minus 3 is 8, cube root of 8 is 2. So you see how this one made 2 become 11, this one makes 11 go back to 2. Inverse, sweet. So do the side that's got less writing on it. See, don't worry about that side yet. Less writing.